Welcome everyone to the online course on Essential of Database Management System. In previous video lecture, we discussed pitfalls in relational database system. In this presentation, we are going to discuss tuple relational calculus. Before that, we will discuss relational calculus. What is meant by relational calculus? It is the non-procedural query language that tells the system what the data to be retrieved, but does not tell how to retrieve it. What are the types of relational calculus? Tuple relational calculus and domain relational calculus. Let's start with tuple relational calculus. The tuple relational calculus is non-procedural query language. Then how to represent the sentence here? T, so such that P of T. So where T is the tuple variable that run over every row. And P of T is the predicate logic expression or condition. So the TRC uses tuple variable T that goes to each row of the table and checks if the predicate is true or false for the given row. Depending on the given predict condition, it returns the row or part of the row. So here the student is the one of the relation. It consists of three columns: roll number, name, and department. And look the question. Find all the data of the student who belongs to the CSE department. Then how to write query here? So the left side T, that is tuple. And then here the right side, the T is belongs to student. That it means for the tuple is belongs to student relation. And what is the condition here? That is the department should be CSE. So then automatically it will filter and it will show the result. So only the Arun and Bala, the two students, only the belongs to CSE department. It will filter and it will show the result. The TRC uses extensional and universal quantifier. We'll discuss one by one. First start with the extensional quantifiers. So its other name is that exists. It is used to express that there is at least one tuple in the relation that satisfies the given conditions. So here there are two tables, student table and enroll table. The student table consists of three columns, roll number, name, and department. And the enroll table, it consists of two columns, roll number and course ID. And look the question. Find the name of the students who are enrolled in any course. So here we are going to find the names only, not all the column. But what is the condition who are enrolled in the any course? Then how to write the query here? So here the first mention the tuple name in the left side. What do you want to display here? For example, name, that is s dot name. So now the S, the tuple, it is belongs to student relation, and E is a tuple that associated with the essential quantifier that is belongs to enroll. So what is the condition? That is the S dot roll number, that is the student roll number should match with the enrolled roll number. That case automatically it will filter and it will show. So what is the output here? That is Arun, Kumar, Lada and Anbu. So this only it is matching with the two table. And next one, universal quantifier. It is also called as for all. It is used to express the condition must hold true for every tuple in the relation. So here consider three table. Student table, it consists of three column, roll number, name and department. And next enrolled table, it consists of two column, roll number and course ID. And third table, course, it consists of two column, course ID, course name. And look the question, find the name of the student who are enrolled in all the courses. That cases you can go for universal quantifier. In particular courses, then you can go for existential. So for example, how to write the query here? That is Finally, we are going to write name, right? So s dot name. We want to display only the name, s dot name. So now the relation tuple s is belongs to student and the C is associated with universal quantifier that is belongs to course. And then E tuple that is associated with extensional quantifier is belongs to enroll. So what is the condition? E dot roll number that is the enrolled roll number should match with the student roll number and the enrolled course ID should match with the course ID. If satisfied, then it will filter and will show. For example, the roll number 1001, it is matched with enrolled table, and then the student, the enrolled two courses, CSE 101 and CSE 102, that is matched with the course. So here CSE 101 OS and CSE 102 DBMS. The BALA is not matched with here because the BALA roll number is 1002. It is not matched with enrolled. Next, the Kumar, the roll number is 2001. It is matching with the roll number enrolled. So he registered two courses, CSE 101 and IT 202. That is again matched with the course ID. So CSE 101 means OS and then IT 202 means that is Java. And then Lala 2002, it is not matched with enrolled. It means not enrolled here. The next one is 3001. Anbu, it is matching with enrolled. He registered only one, he enrolled only one courses, EC E301. Again, it is matched with course table. So EC301, it is ADC. So finally, we are going to display only the name. So the only Arun, Kumar, and Anbu. A TRC formula is built up out of atoms. The relational atom, that is the tuple membership. It means the tuple belongs to the relation. That is, yes, it belongs to relation. And next one is comparison atom. Compare attributes or value using comparison operator. For example, less than, equal, greater than, equal, not equal. So here, s of x, it means that the s of x, it means the value of the attribute x from the tuple variable s. And u of y, it means the value of the attribute y from the tuple of the variable u. So here we are going to compare using comparison operator. Or the s of x, the value of the attribute x from the tuple variable s is compared with any of the constant. And atom is the formula. We'll discuss one by one here. If P1 is the formula, then so are the negation of P1 and P1. If the P1 and P2 are the formulae, then so are P1 or P2, P1 and P2, and P1 implies P2. If P1 of S is the formula containing the free tuple variable S and R is the relation, then S is the tuple, it is associated with extensional quantifier is belongs to relation P1 of S. That is the prediction is should be true. And S is the tuple that is associated with universal quantifier that is related to the relation with the predict condition true. And next one is P1 and P2. It is equivalent to the negation and the negation of P1 or negation of P2. It means just to see the negation into negation here positive. It means negative into negative positive. That is become P1. The negation of or become and. The negation into negation of P2 it become positive. That is P2. And next equation, the universal quantifier. That is the tuple associated with the universal quantifier that belongs to relation. with the predict condition should be true is equivalent to the negation of the tuple associated with existential quantifier. This belongs to R and the negation of P1 of T. The P1 implies P2 is equivalent to negation of P1 or P2. I hope that you will understand this concept.